Volcanoes are among the most spectacular and destructive geologic features on our planet. But what makes them tick? What's the reason that we have volcanoes? As children, we learn that volcanoes exist because the Earth is like an egg with hot, runny yolk inside of it. And while that isn't entirely wrong, it's pretty vague. So let's find out, why are there volcanoes in the first place? First, some terminology. A volcano is a rupture in the crust of a planetary body that allows hot rock, ash, and gases to escape from below the surface. These features aren't exclusive to Earth. They can happen anywhere that there is a hole from the inside out. For example, there are volcanoes on Mars, Venus, and Jupiter's moon Io. The main difference between these volcanic eruptions on other worlds and the ones we used to hear is that they often much more violent and massive than anything we've seen on Earth. Io in particular has hundreds of active volcanoes at any given time. If you want to make a volcano yourself, all you need is a weak spot in the outer layer of a planetary body and hot rock below. On Earth, this layer is called the lithosphere, which includes both the crust and the uppermost part of the mantle. If we were to take a bite out of the Earth and look inside, we would see that the lithosphere is made up of rigid, but incredibly hot rocks. It's hot enough that if you were to leave a metal fork in it, it would eventually melt. In fact, the deeper you go into the Earth, the hotter it gets. This heat comes from two main sources: radioactive elements deep within the planet, and the leftover heat from its formation. The latter is responsible for the fact that the Earth's core is still liquid today. Now, just like oil floats on top of water, the lithosphere also sits on top of something less dense. While the lithosphere is rigid, the asthenosphere is so hot that it behaves more like a very thick fluid. This boundary between the lithosphere and asthenosphere isn't a hard line, but rather a gradient, where the temperature goes from cool to hot. And the exact depth where this transition happens varies depending on where you are on the planet, but it's generally somewhere around 100 kilometers beneath our feet. So knowing this, it should be obvious why volcanoes happen. Hot rock from below the lithosphere pushes its way up through the weak spots, creating a volcano. But why are some volcanoes more active than others? Why do they erupt more frequently, or send lava farther down the slope? Well, that's due to the composition of the magma and the strength of the crust above it. Take, for example, Mount Vesuvius, which you may know as the volcano that destroyed the Roman city of Pompeii in 79 AD. Vesuvius is what's known as a stratovolcano, also called a composite volcano. Stratovolcanoes have steep sides and are made of alternating layers of lava flows and ash. This is why Vesuvius is shaped like a classic volcano. Magma that erupts from stratovolcanoes tends to be viscous, meaning thick and sticky, and that's because it has a high silica content. Silica makes magma more viscous because it creates strong bonds between the atoms in the molten rock. When magma is highly viscous, it doesn't flow very far after an eruption. We can see this in real time at Kilauea in Hawaii. Kilauea's magma is low in silica, which means that it's runnier and the lava flows further before cooling. And because of that, Kilauea doesn't have steep sides like Vesuvius. Instead, it looks more like a shield. That's why it's called a shield volcano. In general, shield volcanoes are found at mid-ocean ridges where new ocean floor is created. In contrast, stratovolcanoes tend to be found further inland where there's more silica in the crust. The exact location of these volcanoes has a lot to do with plate tectonics. Earth's outer layer isn't just one giant piece of rock. Instead, it's made up of several large and small plates that move over the surface of the planet. Volcanoes are most likely to form at the boundaries between these plates. There are three different types of plate boundaries. Divergent boundaries are where plates move away from each other. Convergent boundaries are where plates move toward each other. And transform boundaries are where plates slide past each other horizontally. At divergent boundaries, new crust is created as magma rises up to fill the gap. Iceland, which sits atop the Mid-Atlantic Ridge, is a great example of volcanism at a divergent plate boundary. Magma spills out along the ridge, creating new ocean floor and pushing the North American and Eurasian plates apart. Meanwhile, at convergent plate boundaries, one plate is forced beneath the other in a process called subduction. As the sinking plate descends into the planet, the pressure and temperature increase dramatically. Eventually, the rock is hot enough to melt, creating magma that can work its way up toward the surface, forming volcanoes. The ring of fire that surrounds the Pacific Ocean is home to many volcanoes formed by this process. Finally, transform boundaries are places where plates slide past each other horizontally. Although not much magma is created at these boundaries, the friction can cause the rocks to heat up, creating magma that fuels volcanoes. An example of this is the San Andreas Fault in California. But not all volcanoes are created by plate tectonics. Some occur in places called hotspots. Hotspots are areas where hot rock from deep within the mantle melts through the crust, creating magma. This magma then erupts through the crust, forming a volcano. Unlike volcanoes formed by plate tectonics, hotspot volcanoes don't follow the boundaries between plates. The Hawaiian Islands, including the Big Island of Hawaii, were formed by a hotspot. So why does all this matter? Well, Understanding how volcanoes form helps us predict when and where they might erupt. This knowledge is essential for protecting people who live near volcanoes, because volcanic eruptions can cause significant damage to life and property. Plus, volcanoes are pretty cool to watch, even if you're not a fan of their habit of destroying entire cities. So next time you hear about a volcanic eruption, you'll know exactly what to blame. Thank you for watching this episode. If you liked learning about volcanoes, you'd probably like our podcast. In it, some of the smartest people we know get together for a lightly competitive knowledge showcase. They rack up points for teaching the others, and everyone listening at home the most. Mind-blowing science facts related to the week's theme. And the first 3 people to get 400 points become a podcaster for an entire episode. You can listen to it on various platforms.